Question 2c, we're graphing another inequality. Inequalities will always require some shading on your graph like the last two did. So this says y is less than or equal to a negative absolute value of y plus 2. So this time we don't have a linear equation because we have our absolute value sign in here. So this is an absolute value graph. And the way that we're going to graph our absolute value graph is by knowing what the absolute value of x looks like. So what we're going to look at is what does y equals absolute value of x, our parent function, and then from there we're going to adjust it with our transformations of adding 2 and multiplying by negative out front. So the order pairs for our parent function, the absolute value of x, if we put in a negative 2, the absolute value of negative 2 is 2. If you put in a negative 1, you get a 1. You put in a 0, you get a 0. You put in a 1, you get a 1. And if you put in a 2, you get a 2. So if I graph those order pairs on my graph, then I would have the order pair 0, 0, 1, 1, 2, 2, 1, negative 1, a negative 1, 1, and a negative 2, 2. And that's what this parent function would look like. It would do this. So basically, it's a line with the slope of 1 and the slope of a negative 1. So that's this function here. Now what we want to do is we want to apply our transformations. If we rehearse this, or we go back through what we rehearsed, anytime it's outside the grouping symbols, there's nothing inside the grouping symbols, it's just the absolute value of x. So both of our changes must be vertical. This is a vertical shift downward 2 units. This is a reflection across the x-axis. So I want to perform those 2 transformations. And the first one I'm going to do is I'm just going to follow my order of operations, and it would say I have to multiply by this negative 1 first. So that's going to be our reflection across the x-axis. So now I'm going to do that in red here. So that order pair 0, 0 stays where it is. We reflect this one down, we reflect this one down, reflect this one down, and reflect this one down. And that's the new path of our absolute value. But then we also have to raise it up 2 units. So now I'm just going to save a little time. I'm going to push this graph up 2 units. So I was hoping it would allow me to. Up 2 units there. That's where our new graph is. That's where we have to evaluate this function. So I now have this function graphed. What I want to make sure is I shade in the appropriate regions. So again, since I can test the order pair 0, 0, since it's not on that, I'm going to put in is 0 greater than or equal to the negative of the absolute value of 0 plus 2. So 0, 0 is our test point for these inequalities, and we're going to evaluate is 0 greater than or equal to the absolute value of 0 is 0. The opposite of 0 is still 0, so 0 plus 2 is 0 greater than or equal to a 2. And that, again, is a false statement. So because it is false, I don't want to shade on the inside. That's where the point 0, 0 was. I want to shade on the outside. So all my solutions are on the outside of that absolute value symbol. So we're out here with every one of our answers. So if we want to graph absolute values, make sure that you recognize it's a V-shaped graph by identifying the parent function and then transforming it into its new location so that we can graph all of our possible solution sets.